Hello everyone. In this video, I'm going to further improve the passenger pickup model I did previously. In that one, if you remember, I highly recommend to watch it because this one builds on top of that. In that one, if you remember, I used the signal head to hold back passengers. All passengers were pushing against it, and when I gave green, they basically just rushed through, or one, because it was only able to handle one pedestrian or one passenger. This one is much more improved. It works as same way as the PT line. So it has an area where pedestrians wait. This red one, it also has the same parking system. So vehicles can forward in reverse out or reverse in forward out. I created it the same way, the create park car park tool. It has an area where I load the pedestrians into the model, and I have one that represents like the loading place. And there is one where they exit the network. This model is quite complex. I highly recommend to watch every second of it, otherwise you might miss certain important parts. It uses attribute modifications. We create our own user-defined attributes, and it also uses a script. You don't need to be afraid of the script. You can just copy-paste it from the video. I try to put it to the description if I don't forget, but you can just pause it and write it yourself as a practice. It should be, if you use the naming convention I will set out, it should work for you, and it should be able to handle multiple spaces as well. I didn't test it, but I can, if you want me, I can create a model and show you how to do multiple spaces as well using the same system. Just let me know in the comment section below. So this is the model. The user-defined attributes are here, both for links. One is PU state, passenger pickup state, and this time it is an integer and is data format. Previously I used string or text, but it is easier to deal with when it's a number instead of a text, especially in COM. It's easier to understand, I think, as well, the script. Then the car occupancy is the other one. So in PU state, I store the state or the status of the loading, the pickup. In this user-defined attribute, I store the number of people I want to load into the car. Previously, the model only handled one passenger. In this one, it can handle any, and it chooses randomly. In the car, or for every car, I randomly assign an occupancy number. I take that occupancy number and put it into this car occupancy attribute. For the car, that attribute is a vehicle in network attribute. Here, it is a link attribute. If I use it for the links, it is much easier to access. So, next one is the script. So, you can access scripts from here, event-based scripts. You load in your VBS file. So you create a new text file, you update the extension, you save it as VBS. I wrote it in Visual Basic. If you want, you can do it in Python or in anything else, obviously. The scope is stimulation run. Function name, this is the subroutine's name in VBA, passengers. From time to time, 0 to max, period 1, so every single simulation step, it runs the script. Run type is the end of time step. The end of time step, it is important. Attribute modifications, there are 5 in total. The first one is an initialization. It only runs once when the model starts. And I have 4 that runs in every step. Period is 1. So it runs every step and at the time step start. Initialization is just for every link, I update the PU state to 0. So they are all empty. Then the next one is when a car arrives. It is a link. Car occupancy. This can be 1. I just keep forgetting updating it. So it is 1 car occupancy. This is our user defined attribute. You can select it from here. We use object filters because we want to make sure that we only load the car occupancy from the right vehicle to the right link. So when a vehicle arrives on a car park, we take the occupancy from it and to that link that the parking space is located on, we load it there. So first, we filter down the links. We use 3 conditions. First is the number of vehicles is more than 0 on it. If you click here, you scroll to the bottom, vehicles, and count. And if you double click on it, it will add this. Then PU state is 0, so the space is empty. And there is no loading, nothing going on there. Then the last vehicle dwell time is more than 5. So for the space, there is automatically created a parking routing decision. If you double click or just look on the left, there is a parking duration and there is a time distribution called forever. You need to create it. It is a normal, but can be empirical as well. And it's just basically 1,000. It can be more than that if you want, but I think 1,000 seconds is probably enough. So this way, we keep the vehicle there for at least 1,000 seconds. Whatever happens, it is not going to leave. And then we will update this and reuse it once everything is done. If you want to set like a waiting time, an ultimate waiting time, you can reuse that. Let's say we are waiting for passengers, but we waited for 10 minutes and we don't have all of them. And I still want the vehicle to go. So that way you can just achieve that. Then go back. So that is more than 5. The reason I say 5 is because when we load all pedestrians, when all pedestrians we wanted as passengers, when they disappeared from the network, so basically they arrived to the car, then we set it to 5 seconds. So the vehicle wait 5 seconds after the last passenger got in. This way, we can make sure that this won't be true, whatever happens, and there will be just this 5 seconds. So if it is more than 5, that means there hasn't been any loading yet or anything. Last vehicle dwell time, you can put it from here. So if you go to the bottom, click on vehicles, click on lost, and you select dwell time. Double click and it will give you that. And the formula, car occupancy formula, now we update that. So we filter down all links to the one we are looking at now, where a vehicle arrives. This is important because if you have multiple links, and on one there is a loading, there is waiting, a vehicle is arriving on the fourth one, the next one has something else going on. This way you can filter down that I want this occupancy to be taken at the right moment. So the lost vehicle's occupancy is copied. Again, you can access it by going here. Lost vehicle. Lost means, I have this here. You open the manual and you can find a description what these mean. Yeah. And so we find occupancy, double click there and you will get that one. So this way, if a vehicle comes, let me run it and I can show it step by step. Okay. As you can see, pedestrians have arrived. They just hang, waiting there. They don't do a lot, just walking around. Now I pause it. A vehicle starts loading in, or sorry, reversing in. The vehicle's occupancy is 4, dwell time is 0. So the link should pick up the car occupancy from the car when it stops. And you are not going to see this happening now because there are enough pedestrians. And they already been assigned to the car and remove that. But when there is not enough pedestrians, okay, let me just do that so it is visually easier to understand, because the script updates it when we click the next step. So you can see now, because there is no pedestrian waiting. So the car has 4 and the link has 4 and the PU state is 1. So PU state is 1. We updated first here the occupancy. So this occupancy is now 4. Next up, it has exactly the same conditions, the same links, and the target attribute is PU state instead of occupancy. And here, from 0, representing empty, we go to 1. That means loading time. So 1, 4. The vehicle is now waiting for pedestrians to arrive. There is no pedestrian, so it is waiting. It still has a dwell time of 999. It got the dwell time from the parking routing decision. Now let's go to the script. If you are not interested in it, you can just skip this part. But I think it's quite important. I'm going to go line by line. So here we define variables we use down in the model. You don't need to use here, as in VBA normally, like as integer and stuff like that. You will get an error message if you do so. So you just here set out everything that you use below. There is one big loop. In that big loop, I loop through every link in the system that is in the PU state of 1. So I take a set, a filtered set, all the links I extract into a collection that has a PU state of 1. Very important to note the data type, so it is a string we need to provide to Vissim. That's why the quotation marks. Okay, you can, let me show you. If you go to link to, let's start from Vissim. Vissim, because as you can see, I say vissim.net.links, so you can see Vissim, properties, net, inet. Then within net, I'm looking for what? Links. Links as a property. Then link container, ilink container. So now for the links, you can get a filtered set. And the argument you give is string, is as a string. That's why you need to have the quotation mark. Then you see the syntax is for each link in vissim.links that get filtered set. This is a variable name. I set it. It can be whatever I want, and that whatever I want needs to be in places where it will highlight it with green. So it needs to be the same wherever you see it now. Within that for loop, I create a variable called petFilteredSet, and I do that because what I do is, do you remember when I said that link number is 2 and the area should have the same number? So now I will extract all pedestrians from the model. Basically, I will get another filtered set from all the pedestrians that is on area number 2. And by area number 2, I set it like this. So every pedestrian has an attribute called construction element number. So if it is on an area and the area's number is 2, then construction element number is 2. If the pedestrian is going on a stairway and the stairway has a number of 2, you will get the construction element number is 2. Here, I put construction element number into quotation marks because it needs to be a string. And the number, so if you see here, the number should come. And so I concatenate using this ampersand. I concatenate this, the links number, the link number. So if you see link, attribute number, number. So every link I go through, this for loop goes through every link. It extracts 10 links. In my case, only one link because I have one parking place. But if you have 10 links, you would get as many links as you have it with PU state 1. Then this for loop will put the first link from that collection into this variable and then does everything you want. And then it comes back, then they puts the second one in it, then does the stuff. So here I say link dot add value the number. So this link I extracted. I want to know the number of it. And I assign that number to this construction element. And this CSTR is basically converts this, because this is a number, into a string or a text. And with this, I concatenate it. If you don't put it here, this, you couldn't concatenate. And this needs to be a string. So I just save this string into pet filtered set. And here I say the same. And that for each pet for dwell, this is just a variable, similarly like link. We represent one item, one pedestrian in the collection. So in vissim.net.pedestrians.getFilteredSet. If we go back to the com hub, Vissim, properties, net, inet. There is no collection for network. There is only one. Then pedestrian, then pedestrians container, because there are many pedestrians. And it also has a getFilteredSet method. Now, so I basically now extract from all the 100 pedestrians, the ones that are on an element with number 2. Because in construction element number, the link number is 2, so I just use the construction element number 2. Again, because this has a number 2 and also the link. So I want to extract all pedestrians. I want in a container all the pedestrians that is standing on that area. Then a pet for dwell variable now stores one pedestrian. So if that pedestrian has an attribute value dwell time that is not 0, and the links at value car occupancy is more than 0, then put the pedestrian dwell time to 0. So now the pedestrian that has a dwell time, let me increase the input. So now pedestrian has a dwell time of 1000 as soon as it steps here, because it is set up here. The same for our distribution. So now I reduce that to 0. So it will follow its route. And it has a route from here to here and from here to here. You should be able to do it with a single route as we did previously. Just I thought I'd do it this time. So you can show that you can do it either way. So let's say this area is part of your big pedestrian system where pedestrian will arrive to, and then you can just move them there via this area. So now the dwell time is 0, so they will carry on following their route instead of waiting there. And I also reuse the car occupancy attribute by 1. And so now the link has a car occupancy 4. The pedestrian is going to step, and the dwell time will go to 0, and the car occupancy will reduce. So it's 0 in the next step, and car occupancy is 0, so it needs to take 3 more pads. And if next, that means I go for the next pedestrian. In this case, there is no more, but if there is more, then it will do it as many pedestrians it will do, as many number is left over in car occupancy. Then there is an attribute variable still walking, because if you have a long walking time to the car, or if you have a very busy waiting area, it can be that pedestrians bump into each other too much that it wouldn't arrive to the car. So the car will wait until the pedestrians arrive. Then what I do, I get a collection. This loop is there to deal with pedestrians that are walking towards the car. So I get a collection called, so the variable to deal with that collection is pet for boarding. So in this variable, I will store every pedestrian one by one. From the collection of all pedestrians on area number 2. So in our case, area number 2, this is not nice here, so I should update this. I just forgot that this should be the area number that we use for link. So like that. So item number should be the link attribute value 2. And pads. So the area number is again the same as the link number there. And just when I develop the script, I just put 2 to simplify it. But this way it will work with multiple spaces. Pads. And so area, we go to Vissim. Vissim, net, areas, area container. And you can see there is an item by key, but in area container, so in area, sorry, it took me the container first. No, no, no. So area has a property of pets that returns a collection of pedestrian objects. Pedestrian object referenced by this area. So if I say this, vissim.net.areas, then I select which area by using the item by key, pets. It will create me a collection of those pedestrians, and one item I will store in pet for boarding, and I will iterate or loop through every item, every pedestrian using this for loop. And if pet for boarding at value dwell time is less than 1, that means I have dealt with that pedestrian before because I changed this dwell time to 0. Then in still walking, I increase it by a number, by 1. So basically I count how many pedestrians are still on that area with a dwell time less than 1. So I can count, I can check if there is still a pedestrian walking towards the car. Then I say next, so it will go back to the next pedestrian and so on in this container, or in this collection, sorry, of pedestrians. Then I have an if condition, if still walking is 0 and link at value is 0, and so that means there was enough pedestrian, or there were enough pedestrians on that area to basically fully load the car. If the car needed 1, there was at least 1. If the car wanted 4, the area had 4. So now, because if you see, remember here, I reduce the car occupancy iteratively 1 by 1. And if it reaches 0, remember that. If it reaches 0 and there is no one walking on that area anymore, so everyone arrived to the car, then the PU state goes to 2, more like a loading complete. If that's the case, there is a reuse dwell attribute modification. That's the next. I filter every vehicle to the ones that are on links that has a PU state of 2. I change that with the script. And the dwell time is more than 5. So that means that link been dealt with in the script already, but the car hasn't been dealt with. So the car hasn't been assigned with the new dwell time. So its dwell time hasn't been reduced yet. So now I reduce it to 5. It will wait 5 seconds before it leaves the car park. And then, if the PU state is 2 and the vehicle count is 0, that means the 5 second is gone, has elapsed or expired or whatever. Then the car reversed out or left the space. So there is no more car on it, but the PU state is still 2. In that way, or in that case, the link object target attribute PU state is going to 0. That means it is empty again, and the whole thing can start again. It was a lot of fun, I know, but this works quite nicely and is quite a capable tool. The car waits, then they wait for the next one. That car had probably 1 occupancy. Probably it has more than 1. Sorry, more than 2, because 2 have already got in. It waits for the 4th one, waits 5 seconds and then goes. So as you can see, this is quite a good useful stuff. Let me know if you want to see a model where you have more of these spaces. And if you like what you see, please consider like and subscribe. That would help my channel. And also, if you want to support me, you can do that by going to my Patreon page and pledge your support by a few dollars. It's not a lot, but would help the channel a lot. Thanks for watching and see you in the next one.